Hi, my name is Jay. I am a cloud security researcher with Palo Alto Network. My research has been focusing on cloud native security. And today I am presenting with my coworker, Nathaniel Quist.
Hi, my name is Nathaniel. I'm a senior threat researcher with Palo Alto Networks and Unit 42. My primary focus is cloud security and who's attacking it and how.
So in the first half of the talk, I will first go over an interesting red team exercise that we did in 2020. I will start with some introduction about the identity and access management in AWS. With the background, I will then go into the detail of our red team exercise. And after the exercise, I will cover an extended research that we did after the red team exercise to identify the misconfiguration that we found during the red team exercise in the wild. In the second half of the presentation, Q will cover the evidence-based findings that we saw in our internal dataset. Then he will also present some interesting findings related to cryptojacking in the cloud. And finally, we will conclude the talk with a set of best practice in cyber hygiene to help audience remediate and prevent the misconfiguration that we have seen. The fundamental concept of identity and access management is very simple. It basically determines what for a principal, what are the actions that the principal can perform on a set of resources. And the principal can be a user or an application, and the actions can be like read, write, or execute. And the resource can be file, functions, or database. And when we put the IAM in the cloud environment like AWS, the principal can be a user, a role, or a federated user, or even an application. And the action that the principal can perform depend on the resource. For example, in AWS, there's EC2 service for virtual machine. And within EC2, there are a set of actions such as run instance, start instance, or stop instances. And in case of S3 bucket service, there are also a set of services such as create bucket, delete bucket, and list bucket. In AWS, currently there are more than 200 different services. You can essentially find a service for any kind of application that you can think of. And for each service, usually there are a set of more than 50 actions that can be configured for a specific service. And out of the box, when you create an AWS account, there are 500 preset managed policies that AWS define for all the AWS users. So with so many services and so many actions, it is not an easy job to manage identity and access. Imagine that you are responsible for a cloud account with hundreds of users, hundreds of developers in an organization. It is impossible to define a policy, a permission policy for each users. As a system admin, you probably don't want those engineers come to you every day for different service. So in reality, the principle of least privilege is not that easy, especially in a cloud environment. So in 2020, during an engagement with our customers, we worked with them to perform a red team exercise to evaluate their cloud environment, their AWS environment. And the outcome of this red team exercise is that we found a few critical and interesting misconfiguration that allow us to take over the account. We start with threat modeling the environment, and we look at the environment from different aspects. And today, I will just cover the two most interesting findings that we had during the red team exercise. in particular to identity and asset management misconfiguration that allow us to compromise their cloud environment. The first misconfiguration is an overly permissive permission policies. So we started as a developer. We were given a developer permission to emulate an insider attack or an permission leak type of attack, in which engineer or developer's account was stolen, and the attacker can use those stolen account to pivot inside the account. So the first misconfiguration we saw is that with a developer account, we can put together a set of overly permissive permissions and eventually gain the administration access privilege. Admin access is the highest privilege in AWS account. It's like a root user in Linux. And the second misconfiguration is an overly permissive IAM trust policy. In this particular scenario, we started as an outsider. As penetration tester, we did not have any permission and zero privilege in the client's environment. However, due to a misconfigured IAM role trust policy in that particular account that we are testing, we are able to gain the initial foothold into their cloud as an anonymous user and eventually pivot from the initial foothold to other service and access some highly sensitive data in that cloud environment. So I will first go over the first misconfiguration. Before going to the detail, I will first cover two important concepts in order to understand this misconfiguration. Service role is a type of role in AWS environment that is assigned to service such as EC2, ECS, or Lambda. Service role grants service permission to access cloud resource. For example, a service role can be attached to an EC2 instance, a virtual machine, and this virtual machine, after being attached with this service role, it can start to access cloud resources such as Lambda function, S3 bucket, or key management service. So this is a special type of role that is assigned to AWS service, not users. And the second concept is called IAM pass role. Pass role is a special action in identity access management. So this pass role permission allows a principal to attach a service to a service role to a service. For example, if I'm a user and I have the pass role permission, I can create an EC2 instance and attach a role, a service role to this VM. And this VM can then use the permissions associated with the service role to access the AWS resources. Graphically, so I am a user and I have the pass role permission, and I can first create an EC2 instance and attach a service role to this instance. And this instance then can use the service role to access other AWS resources, such as AWS KMS, AWS Translate. So as I mentioned earlier, we started as a developer. We were in this exercise, we were given as a developer, we were given developer role, and we were given a set of permissions as there as hundreds of other developers in the same cloud environment. So we first checked the permissions that we were given in this developer role, and the particular permission that immediately caught our attention is the IAM pass role. Why is this special? What is this pass row action is so interesting. The reason is that it's really about the configuration of this permission. We were able, with this permission, we were able to pass any service to any row we want. This is because of the resource, the asterisk symbol in this policy. This policy allows us to pass any row to any service. Then we start to check what are the services that we are allowed to pass. So there are a set of service rows in this AWS account that we are testing. And we look into each service row to check their permission. And luckily, there are a few service rows that have admin access, the highest privilege in an AWS account. So now we have a pass row permission that allows us to pass any service row. And we also find a service row, like not just one, multiple service row that has admin permission. So now we have multiple attack paths. And this is just one of the examples that we can pull this attack. So we, just like I described earlier, we first create an EC2 instance, then we attach a service row with admin permission to this instance. Because we created the EC2 instance, we can log in, we have the credential, we can then log into this virtual machine and start to access the cloud, access the entire cloud from this virtual machine. So what I described here is just one of the possible attack paths, because we also have access to other services such as Lambda function and ECS container service. We can also perform the same type of attack using other services such as Lambda function or ECS container service. Now let's look at the second misconfiguration, overly permissive IAM row trust policies. In order to understand this misconfiguration, again, I will first cover two important concepts in IAM. So each IAM row is associated with two policies. The first one is trust policy, and the second is permission policy. A trust policy defines who can assume or use this row. So in this example, this trust policy grant permission to EC2 service. So only EC2 service can assume and use this row to perform action. And the second policy, permission policy, defines what actions that the principals can perform. So now we understand the trust policy and permission policy. Now we can look at the root cause of the second misconfiguration. In this particular, the root cause of this misconfiguration is due to overly permissive trust policy. So this is the trust policy that we saw in the client's environment, a trust policy that grants everyone permission to access, to use or assume this row. As I highlight in the red box, AWS followed by AWS is the asterisk, meaning that anyone can assume and use this row. And this any person within or outside the cloud, you don't need to be a user in this particular cloud environment. You can be any user in other cloud environment. As long as you know the name of this row, then you can gain the access to this cloud environment. So this is like having a SH server with users that can be logged in without a password. All you need to know is a username, then you can access the host. So this is a very bad misconfiguration that allow us to gain the initial foothold to the customer's cloud environment. In the next few slides, I will explain how we actually exploit the misconfiguration and move laterally in the cloud environment. So as I say, because of this misconfiguration, we as outsiders can gain the access to the to the cloud environment. So by assuming this misconfigured role, we were given a short-term access token. And once we get the short-term access token, the first thing we did is to enumerate the permission, to identify what are the permissions that were granted to this particular role that was misconfigured. So we found that this token can access 3 AWS services: EC2, S3, and KMS service. And the configuration of the permission configuration of this role is actually very limited. For each service, such as EC2, it only grants a very small set of permissions. However, we are able to use and leverage this small subset of permission to move laterally inside the cloud environment and eventually gain the critical information, the sensitive data. So to be in particular with the EC2 permission, we look inside the metadata of the EC2s in the cloud environment, and from the metadata we identify a set of S3 buckets that this EC2 instance access. Then from those S3 buckets, because we have the S3 list and get permission, we can also access those S3 buckets. And inside those S3 buckets, we found a lot of sensitive information. So the exact information, the exact data we saw in these S3 buckets are the certificate, credential, API tokens, and many others. Then we also found encrypted credential stored inside this S3 bucket, which we were able to decrypt with the KMS service that were also in this row. So with KMS, we decrypt the encrypted message inside the S3 bucket, and that also allow us to eventually gain the access to their source code repository in GitHub, in Docker Hub. The second misconfiguration was really simple, just a simple misconfiguration that allow us to gain the initial foothold and start to move laterally. After the rating exercise, we were very curious how prevalent this type of misconfiguration is in the wild. So we start a GitHub reconnaissance research in which we try to identify this type of misconfigured IAM trust policy in the wild. So what we did is that we first crawled the entire GitHub to find the AWS resource, the AWS account IDs, and the possible IAM role names in these IDs. So we basically use a lot of regular expression to parse out the AWS 12-digit account IDs from these files and parse a bunch of possible role names and keywords. Then we start to enumerate a set of role names against these AWS account IDs to find if any of these role names are misconfigured. So what we eventually had is that we went through around 300,000 files out of around 150 repositories. Then we successfully identified almost 70,000 role names, valid role names in this AWS account. And we found a subset of these roles. We found a subset of roles that were misconfigured. And out of these misconfigured roles, we found more than thousands of EC2 snapshots and more than 100 of S3 buckets that we can access, and a lot of key management service keys that we can use to decrypt the data in those misconfigured cloud environments. Now I'll give the floor to Q to continue the second half of the talk.
All right, thanks, Jay. Really good information in here. So within this next section of the talk, we're going to be talking about information that we've looked at across multiple cloud environments, and we're looking at the data that we have actually found from these environments that can lead to potential risks that we saw within our red team exercise that we performed. And then we're going to dive into some of the cryptojacking incidents and how they actually can relate back into some of the past role functions, or even the misconfigured IAM trust policies that Jay just alluded to. So first off, we're going to look at the evidence-based findings. So within these aspects, again, we wanted to look at identity as a whole, identity and access management. And we dove into specific cloud environments to see if we could find examples of potential threats that are in cloud environments today that could, bring about potential security risks or compromise. So the first section we want to look at here is overly prescribed permissions. And this is exactly what Jay was just talking about. What are these permissions that are assigned to specific IAM role accounts? And what can they actually do? One of the biggest threats that we saw was we found that 62% of cloud organizations on a global scale actually that are using Google Cloud, so Google Cloud Platform, their VMs inside of the Google Cloud Platform are actually running underneath admin rights or elevated service accounts that have admin privileges within them. So 62% of all cloud organizations using Google Cloud Platform saw this particular risk. The JPAC region actually had the highest, about 75% of organizations within that particular region. So pretty high, about 3/4 of organizations allowing basically admin access to their VM instances. With the access keys that, again, Jay was just talking about, when it comes to the access keys that we may be able to scrape or glean from GitHub, or if we're able to find specific access keys within cloud instances themselves, let's say an attacker may find an access key within that. We found that these access keys are not being rotated on a regular basis. So we looked at access keys or cloud environments that have access keys that are in excess of 90 days old, so older than 90 days. We found that 68% of organizations that are using the cloud on a global basis have access keys that are older than 90 days. EMEA topped out within the regionality of these particular alerts. 72% of cloud organizations located within EMEA saw that access keys were older than 90 days. Something else very serious, this last slide right here, 24% of organizations have enabled multi-factor authentication for their root accounts, which means that 76% of organizations have not enabled MFA for their root accounts. It's just it's a staggering number that MFA is just, while it's not a foolproof sort of security mitigation tactic, it is something that makes the ability to log into that particular account a whole lot more difficult, raises the bar significantly. So getting our cloud environments or cloud IAM roles, especially those with root privileges or administrative access, getting those with MFA is a key target that we should all focus on within our cloud environments. In contrast to just traditional or standard user IAM role, we found that 47% of traditional IAM roles are actually enabled with multi-factor authentication as well. So still not great, almost half of all the accounts doing that. So again, I think there's some areas where we as an industry, as a security industry, can actually push our DevOps and IT communities to kind of shore up some of these identity and access management credentials and issues that we have with them. We're going to transition a little bit. One thing that we talked about within our cloud threat report as well within this last one here was cryptojacking. Specifically, we found that 23% of cloud organizations or environments worldwide experience some sort of communication or cryptojacking or crypto mining operation network communications within their cloud environments. That's nearly a quarter of all cloud environments actually doing some sort of communication with these mining pools. So what does a cryptojacking operation actually look like? We Within this, well, we're going to talk about two specific crypto mining operations, specifically with Kinsing and another one with Team TNT. Both of these cryptojacking groups are actually actively targeting AWS environments. And they're specifically targeting those AWS environments to grab their AWS credentials out of it. How they operate in general is they perform they cast a very wide net using scanning tools like MassScan or PNScan. They've also started using other tools like zgrab, which is a Golang based network scanner as well. And they're focusing on when they find exploitable systems that are exposed and then exploited, their very first action is to gather and capture the AWS credentials on those particular endpoints. If that AWS configuration folder does exist on those endpoints, they will scrape those credentials and then send them off to their command and control node, so they can most likely perform post-exploitation operations. Let's refer back to what Jay was talking about with both the first and the second scenario within his talk, portion of the talk, in that if you know the access keys and the access ID for a particular account, are there misconfigured permissions within those particular roles that you can leverage to gain larger access outside of those instances? So we see that cryptojacking operations are not just targeting the specific instances, they're actually most likely targeting the larger cloud environment in order to do additional damage or additional information gathering. One thing of note that we'd really like to say within most cryptojacking operations is there is a lot of commonality within most, not just Kinsing or Team TNT, but with other groups like Rock and Pacha and 8220, Lemon Duck, a lot of different ones as well, is that they're very active at removing other miners on those systems, on those endpoints that they compromise. They're very active about scanning for exposed systems. Using MassScan specifically is a very common tool. zgrab is another one that's becoming very common as well. And we see more and more groups also following the Kinsing and Team TNT trend in that they're trying to do AWS credential scraping as well. Unit 42 just published a blog just a little bit ago. Jay was a co-author for that, specifically focused on Team TNT and how they're actually also grabbing Kubernetes credentials as well, so they can actually start targeting that network mesh that Kubernetes has, so they can exploit that as well as AWS credential scraping. So it's not just a cryptojacking. There is a trend towards larger and larger target bases within cloud. All right, so now we want to talk about the mitigation aspects. This will kind of cover both what Jay just presented as well as the evidence-based findings and then the cryptojacking information that I just covered. How does this talk kind of apply to the larger RSA conference agenda, and specifically looking at the educate plus learning and how do we actually apply that as an industry? For our perspective within this talk is we wanted to provide the education aspect, being that seeking out new research. Jay and I performed a red team exercise, which we've gone over. We're looking at cryptojacking, which is one of the largest threats that we see within our environment, within cloud organizations, just kind of in general, and then how those affect your environment or your infrastructure. And that's where the learning aspect kind of comes into this, with the evaluating your cloud environment itself. Can you identify that policies are performed accurately, that you're not seeing network communications to cryptojacking operations, et cetera? And then how do we apply that? If we do see those, how do we actually apply specific security measures, or how do we apply the mitigations that Jay's covered, and then I'll jump into here in a second. How do we bring those into your environment so you can actually have a more secure cloud environment in your system? So specifically within the mitigation aspects, as far as identity and access management, there are specific best practices that we would encourage cloud organizations to perform. Going around this, we really want to encourage organizations not to use cloud or root accounts within their cloud environments. Specifically within the example I gave earlier with Google Cloud Platform, with 67% of those organizations providing VM or root access to their VM instances, removing that root access and just making it specifically to a specific service or a very specific least privileged account role. Minimizing the use just across the board of admin credentials. Again, using that least privileged capability to only give that particular service or IAM user role only the credentials and the access they need in order to perform those services that they're deemed to use. Simplifying the user management as a whole, using groups, using roles, assigning IAM users to specific roles or specific groups will simplify the task and the burden of managing and maintaining IAM accounts. So using some sort of hierarchical form that is easy to understand but still granular enough to perform least privileged functions should be used. Rotate your access keys on a regular basis. As Jay said before, using some sort of automation in order to perform that functionality will greatly enable the security of your cloud infrastructure. And then if you do use it, like use passwords like Azure organizations allow you to use, make sure that your passwords are actually of a significant length and are secure passwords. As far as the configuration of your infrastructure, your identity and access management infrastructure, enabling multi-factor authentication will greatly increase the bar. It will not make it impenetrable, but it will significantly increase the bar and security within your cloud environment. So enabling that is a key aspect. Doing some sort of monitoring within the APIs that are being sent to your identity access services roles, what your cloud environment, monitoring the APIs for specific threats or security risks is a really big bonus as well. Auto remediating excessive privileges. If you have user accounts that have not logged in an exceedingly long period of time, removing the access for those particular accounts is recommended, and then finding some way to remove, especially administrative access from user accounts that just don't need it. Finding some way to do that. And again, leaving this one for the best for last here. Enable least privileges. Make sure that only the accounts that need to access a specific service or function, that's the only thing they can access. They don't have anything excess enabled. When it comes to cryptojacking, there are about 5 best practices that we can look at. We want to ensure that you're authenticating all of the container service connections, ensuring that you're not making connections to services or external IP addresses that are not known to your cloud environment. Make sure that you're monitoring those. Blocking all firewall ports by default. Don't allow access to everything, both inbound and outbound, ingress, egress traffic. Make sure that you're specifically allocating what access needs to be assigned for what service. Invest in some cloud threat native security platform, be that Prisma Cloud or others. Something that can monitor your cloud environment to ensure that you're performing best practices for configurations, both of your IAM, your network security, etc. Leveraging intelligence feeds, using third-party sources to bring into your environment, so you can you're enabling the blocking of blacklisted IP addresses or domains that are known to the industry in general, or that it can be gathered from an intelligence threat feed, making sure that you're leveraging those to protect your environment. And then maintaining a set of trusted images and registries. Only deploy images or containered images that are proofed, that are vetted in your environment, so you're not bringing out tainted or corrupted or poisoned containers in your environment. All right, that wraps up our discussion. If there are any questions, we will refer to those. And thank you very much for attending this talk. Appreciate it.